Cool. All right, this is just an experiment. I just thought I would play around with, here I'll pop out this chat, keep this over in the corner. I'll put it right on top of, right underneath my head. So I just wanted to play around with ChatGPT and engineering work and see where it can help, where it hurts, what we can do, like what's possible now that we have these generative AI models, and then what are the ethics involved, like what can I claim as my own work versus what do I have to give credit to. So here for today, I love biking. One of the things that I do every day is bike here to University of Connecticut. So I want to figure out, like, when I'm putting in a certain amount of power into my bike, where's that power going? There's drag, friction. So let's see what ChatGPT thinks. So I want to create an engineering equation that shows how fast my bike will travel when I input a certain power, let's tell it P, and I have to overcome drag and rolling resistance. Let's see what we get from here. So there's force of drag, force of rolling resistance. Let's see what it gives us for equations. Cool. Force of drag, that one makes sense. Force of rolling resistance, some kind of coefficient R. And then power is going to be that term. All right, cool. So far, so good. And I guess right now, what it's assuming is that I'm traveling at a constant speed. And, you know, that could be okay. But right now, it's saying that for my power, I'm going to be moving at some speed. That drag is proportional to speed squared, and then the rolling resistance is a constant result. So this is rearranging for P. So let's see if we can. I want you to also incorporate the changes in kinetic energy in this power equation, and then give me a Python function to solve for speed given a power input. So let's see, now it's saying, okay, so it's giving me that the change in kinetic energy is going to be this 1/2 md v squared dt, so mva, all right? And so far, it looks like it's giving us the right kind of equation. So like ma equals these forces in here, and then that power in there. So let's see what it gives us for this bike speed. And power balance minus P. And giving our average power of 200 watts, coefficient of drag 0.9. Might be a little high for, but let's see how it works. So I'll get my get Jupyter Lab up and running. Copy that link in. And let's make just a new Python notebook, and we'll paste this in. And I haven't really changed anything. I like to separate out some of these in here. So 8.49 meters per second. Let's convert that. Oh yeah, we'll just ask, since we have ChatGPT running, might as well run these servers. So let's say convert speed in meter per second to mile per hour. 2.23. I'm just gonna grab this factor. So if I'm doing 1 meter per second, I'm doing 2.23. So my speed is gonna be times that. And mile per hour. So 19 miles an hour if we're doing, let's see, we have 200 watts, coefficient of drag is 0.9, frontal area of my bike is 1/2 meter squared. I've got air density 1.225 kilogram per meter cubed, rolling resistance 0.005. Let's ask where that rolling resistance. How did you determine rolling resistance is 0.005? So it's giving some background here. But it's not really telling me where this information is coming from. So if I'm, at least for me, if I'm as an engineer, like these kind of things, they need either something that I can say this is how I know that, or there's a reference of like someone else figured it out, and so so let's get in here. Show me some example references that use this value. And we'll send that. Try sending this one. And bicycling science. I don't know if that one's real. Tire manufacturer. Okay. This one maybe. Journal of International. And the thing, I guess the thing to look out for here is that sometimes these things are made up, or the references. So Bicycling Science is a real book, and it is by David Gordon Wilson. I can't really look at it right now. Let's see if I've got search inside rolling resistance. I'm just trying to see rolling resistance data. Human senses. So I'm looking for a case, like a reference in this book where it says like rolling resistance is something. Coefficient of CR 0.06 at low speeds. And we had 0.005 in there. And let's see, we'll go to this website, see if that one. Let's see if we can find rolling resistance on their website. It's a product search. We're not looking for a product. Yeah, I don't know. I don't see any data and figures. Foundation, Schwalbe. I don't think this is really going to give me. Yeah. So ChatGPT, I guess this is one of the things that really whenever I'm using ChatGPT to do engineering work, it gives me reasoning that because the model, because it's a transform model that's meant to create words that sound convincing, it does a good job of finding references that sound convincing, but not actually showing me where in that reference this data is coming from. And same thing here, like where it's saying Schwalbe is a tire manufacturer, like that's true, but the fact that Schwalbe says that their rolling resistance is 0.4 to 0.5%, I can't find that on their website. Let's go to the journal. And this one is just a journal, a test in racing tire. So I'm searching for the journal and trying to figure out, do they mention human performance in road racing, motorcycle road racing? Wheelchair racing. I can't find bicycle racing tires. Rolling performance during cross-country mountain biking. Yeah, I don't know. I don't see that. So, and this has been my experience so far, is that when I'm using ChatGPT to say, like, give me some engineering information, create some functions for me, like it can create the function, but how it sets up these parameters for me to run, they're kind of hit or miss. I don't. So let's do this. Let's use that. So let's call this, use that bike speed calculator to create a website with variable inputs, variable slider inputs for power, drag coefficient, area, rolling resistance, CR, and total mass, M. All right, so now we're getting some HTML. Let's see what this one looks like. It's giving us some slider labels, frontal area, rolling resistance. Let's see, minimum is 50, max is 120. Rolling resistance goes up to 0.01 down to 0.003. All right, cool. And let's copy this. And now I'm gonna make new thing over here. Let's make new directory called AI Playground. Go into AI Playground. Bike speed, VI, webspeed.html. And then I'm just going to paste in all of that HTML work and save it. I like Vim for my coding platform. Let's save, and then just say Google Chrome and look at that WebSpeed HTML. All right, so I can do power, decreasing power, and it keeps increasing or decreasing my speed. So up to 26.5 miles per hour. The drag coefficient, I could change this. 0.5, so down to 0.5 and up to 1.2. 1.2 is pretty high, that's like beach cruiser. Let's pretend we're a beach cruiser. So we'll increase our frontal area to like 0.8. It's weird, the way this thing drag coefficient is like on two lines. I don't like the way that it formatted everything. So rolling resistance coefficient. So for our beach cruiser, it'll be pretty high. And then total mass, we're gonna bump that up to like 100 kilogram. Now, beach cruiser with 220 watts is only doing 14 miles an hour versus a nice beach cruiser speed, 100 watts, kind of taking it easy, doing 10.1 miles per hour. And so one of the things that I find like really interesting, and I'm starting to do this to play around with like, what do I think I own as I'm building this, and what can I claim as my own work? So within a few minutes, I was able to kind of identify what are some ways that I can incorporate like power, drag, rolling resistance, and mass into this like bike speed calculator, and then even create a website. And if I want, I could even push this website up onto GitHub, and then have like a website that anyone can use, because it's just static. At this point, it's all static HTML. Like all this. This could be whatever I want, and I could change this around. Like especially with the labels in here. Let's see. want to make, I would like to make it, I would have to play around with, I guess I could just ask ChatGPT to, okay, remake the website, but with 2 bike speed calculators, and make each slider and label have extra space between them. And I said between them, I should have specified between each slider and label, but we'll see how it goes. It's going to build it. And let's just remove WebSpeed HTML, make a new one. Change it to pasting. Now it's calculator 1, calculator 2. Oh, binary search to approximate the speed. What is it doing that one for? Anyway. All right, so I copied that code. Let's paste it over. I'm not even gonna, well, I mean, I would like to see what's going on here. Why is it using a binary search there? Drag power plus. So I guess it's plugging in those and returning that. So now it's power balance for a given speed. All right, we'll give it a shot. Refresh. Look at this. Dual speed calculator. So let's say person 1, I would change this to like person 1. Person 1's doing 300 watts. Person 2 is doing 200 watts, but person 1 has high drag, person 2 has low drag. Like we'll go half the drag coefficient, 0.45. Oh, 0.5. So according to this, person 2 with, if you can decrease your drag coefficient by 1/2, that's pretty hot. That's a lot of changes for drag coefficient. But let's say this person on the left, calculator 1, is just wearing baggy jeans and not really caring about drag. Meanwhile, person 2 has the teardrop helmet and all of that. So I don't know, maybe that would be about right, that they're doing 1 mile an hour faster than person 1. So in this case, when I'm thinking about like me as the engineer, what did I add to this dual bike speed calculator? So now I have a website. I could publish this. I could put my name on it. Here, let's get in here, start changing it, right? So I've got dual bike speed calculator, and I want to add a subtitle. Oh yeah. I want to add down here, oh, header 2 by Ryan C. Cooper. Header 2. Refresh. And look, now I have taken a ChatGPT website. Now I have my own website, right? And again, like I can take this whole thing, copy it. yeah, copy this thing, put it online, save that for some other time. But I can change this, and yeah, I can look at the effect of rolling resistance. So here, like really high rolling resistance, really low, versus like how much power we're inputting. So at some point it should, I would think higher power rolling resistance has less of an, like as you keep getting faster and faster, then drag will have a bigger effect. Make mass. Yeah, so if the only difference is rolling resistance, but and drag doesn't have much of an effect. So with less mass, drag is going to have a bigger effect. Now we're getting to the point where rolling resistance has no effect if drag becomes a dominant factor. But what can I? So I have all this. Like I have kind of a traceable-ish set. I can copy each of these prompts that I did and say like, hey, I did some prompt engineering, and these are the things that I added to this. So keeping track of what work I was considering, I'm the one who said there's drag and rolling resistance, but I didn't actually come up with these equations to say this is drag, that's rolling resistance. I can go find like what is the equation for force of drag, and it's the first thing that comes up. So, and I can go to NASA's website, like I can get real references for this kind of, these are made up really from ChatGPT. This is all made up. Like it's taken a lot of real information and it's kind of processing it through all these transform vectors, all these like transformations to get it to look like it's real. But there's nothing to force this to be a true statement. There's never anything kind of checking that other than me like taking a look at this and seeing like, is this really drag? And yeah, it actually is drag. And are these terms real? Some of them seem kind of real, others not so much. I can get Python functions. I can get nice like interactive websites where I can start comparing things. So it's pretty cool. But in terms of like, what can I, if I want to say that this is my website, I mean, kind of, not really. I haven't really added a lot other than my name to this website right now. I haven't changed any of the updating things. So here, like, really, I would want to say like rider 1, and this one I would say like, rider 2 to get in there, and probably change the comment in here, rider 2. Undo that. And this is just a comment in here, the fact that it has that. But now I've got something to compare like one rider versus another rider. So if I'm looking at like different areas for different riders, different coefficients, or refresh it, get it back to what it originally was. So in terms of like, what is my intellectual property, and like ethically, can I say that this is my work? I wouldn't claim that this is all mine, because a lot of this came from just outputs from this conversation with ChatGPT. I didn't look up this conversion factor. It is right, but because if we look up convert meter per second to mph, 2.23694, 2.23694. So a lot of this is getting the right information into the right place, but I do want to make sure that I have that I'm checking each of these things before I go in and say like, okay, this is mine and this is how, like especially these rolling resistance coefficients. Like, well, they're so far we haven't found anything that actually says this is the rolling resistance. The way that I would do it is go into like rolling resistance. There's a whole website dedicated to rolling resistance of tires. So if we just click on their very first, like the latest test that they did, we can come down here and figure out like, it was the power required to roll this tire with a 28 millimeter, well, what is this one? So 28 millimeter width was 15.7 watts. And here that rolling resistance is going to be, and let's grab this, bring it over here. Well, actually, I'm going to bring it over there. I'll bring this one over there so that I can say CRR is the rolling resistance. So it's 15.7 watts divided by the speed, which was 18 miles an hour, divided by 18, and 18 was that 2.23694, get it into meters per second, and then divided by the load. So the load was 42.5 kilograms, 42.5, but make sure that that's in newtons. So according to this test, rolling resistance was 0009 rather than 005. Let's make sure that I'm doing this right. So 15.7 watts divided by 18 times, or wait, that one should be, and then times that, times this. Okay, 0.00467. So pretty close to that original value, but now I've got like a real tire website in here, right? Oh, not below. So what is this one? This is the paste in the website and say it's the Vittoria Ride Armor TLR 28 rolling resistance power is 15.7 watts. CRR is, let's get us a little closer. CRR is P speed times the normal force times the load. Let's do this. C dot C dot and over speed times load. Is that right? Did I already miss it? So CRR, yeah, so power over speed times load. Cool. And now I've got my own kind of justified version of that. So I guess the main thing here is that if I'm trying to like build my own dual bike speed calculator, I want to go through and double check all the information that this thing is giving me. And I can ask for references like I did here, but it's almost more work to filter through these references that are really just like transforms. Like they seem like they are references that would fit this conversation, so it seems to work. But in practice, it's not really giving me real information. But anyway, I'll come back next week and try this again. I think this is kind of fun, just playing around with how I can build websites and share things. And then I'll share like this HTML code. So now we have like a little bike speed calculator. All right, thanks for joining and thanks for watching. See you again next time.